Good day. Welcome to our today's lesson on variation. When we mention variation, we simply mean how two items are related. So there are two ways we can maybe approach variation. Okay, it's either they will be related directly or they will be related inversely. And worst case, they could also be related partially. Okay, for instance, let's say a certain behavior is directly proportional to this. So let's say, for instance, I have a whole human being. Then we say, okay, your health depends on what you eat or the life activities that you do. Okay, so when we do that, then we can say, okay, proper health is directly proportional to the healthy lifestyle or the food you eat. Okay, so it means that whenever you eat a healthy food, you get a healthy life. Okay, so that's direct relation. But when we say inverse, then it's more like when this is rising, this is rather declining. So for instance, intake of alcohol can derail your health, right? So it means that as your intake for alcohol or any other drug is on the rise, then your health is also deteriorating like that. So then we say that, okay, intake of alcohol is inversely proportional to a good life. You see, so in variation, we are just coming to see how two quantities actually relate. Okay, so we start from the first one, which is direct relationship or direct variation. So we have the direct variation. Okay, so under the direct variation, like I earlier on explained, this one is the two quantities have direct relationship. So as this is rising, this is also on the rise. Okay, so the general format of variation is, we have the first quantity who vary inversely or directly to AB and the second quantity. So since you are creating direct relationship, then we will say this. Okay, so it means that the item V or quantity V relates directly to quantity R. Fine. So what this means is that if this is, say, in electricity voltage and this is current, meaning that when the current voltage is going up, the current will also be going up, right? But then this particular character is not any of the operations in mathematics. Okay, this particular character is not part of any of the operations. It only represents the word vary. Okay, it represents vary. So since it represents vary is not an operation in mathematics. So it means that we must find a way of changing this vary symbol into an operation. Okay, so before you change the vary symbol, then we have to introduce an equation involving an equal sign and then a constant. Okay, we call it constant of proportionality. So we introduce an equal sign and then a constant. So with this, introducing the constant of proportionality and the equation sign, then this is going to be equal to, and then you introduce k. Okay, so doing so now, then this now we can actually find any of the values given the order. Okay, provided we know the constant of proportionality. So in every variation, though this is varying and this is varying, there is a bit of a part of it that is constant. Okay, so that's the constant of proportionality. So every variation question given to you, first you represent it using the variation character. Then afterwards, you must change that variation symbol into the equal sign with what? The constant k. Okay, so that is how we are going to play this. So in this kind of statement, it would have been v varies directly as I. So v varies directly as I. So it means that this is how you write the equation. Or when you want to write it in a variation format, v varies directly as I. Okay, so they are on the same line. So that's what? A direct variation. Same way, you can say q varies directly as maybe p. So that would be q varies directly as what? P. So when it say direct variation, it's always what? On the same line, using the variation. Okay. So now that we know this, every variation question, they will first of all give you two inputs, both the I and then the V. In this our case, they will give you the values for them. So they will tell you when V is this, I is this. That particular statement is to help you to get the constant of what? Proportionality. So that particular statement will help you to get the constant of proportionality. So that if you know the constant of proportionality, then any one which is given, you can find the order. Okay? So that is how variation is going to be. So the question could be, V varies directly as I. Okay? When V is, say, 6. When V is 6, I is 3. Okay? So when V is 6, I is 3. When you have this, what it means is that the moment that you set V as 6, the value for I should be what? 3. So when we put this statement into our variation formula, we would have had 6 is equal to what? K times what? 3. Okay, 6 is equal to K times 3. So in other words, 6 is equal to 3K. So then you divide 2 by 3, you divide 2 by 3, then just put it there. And then K is actually what? 2. Are you okay? So it means that we got our constant of proportionality due to this statement. They said that when V is 6, I is 3. That is supposed to help you to get the constant of proportionality. So if you want to finally rewrite the variation question in terms of using the constant of proportionality, then we will say that, okay, then our final variation equation is going to be V is equal to 2 times what? I, where the 2 now represent the K. So it means that any value I give for V, I can make I the subject and find. Any value I get for I can find what? V. And so that is how always we put a direct variation question. So here, let's say I can ask you find I when V is a 12. So you are supposed to find I when V is a 12. Okay. So all you need to do is to put the V here into your main equation, and then you have your answer. So I have my variation to be V is equal to 2I. Now my V here is 12 now. Therefore, if I should put this 12 in place of the V, I'm going to get 12 is equal to 2I. Hence my I is going to be 12 over 2, and then I is going to be 6. Okay? So you can always find whatever you have when you are giving one of the values. Okay. So first of all, the most important thing in direct variation is generating your variation relationship or equation. After you do so, then you must determine the constant of proportionality. After determining that, then you have your final variation equation. which will involve only the two quantities that are understood. Then if they give you one of them, then you only insert it into the equation, make the other the subject, and that's all. So here we can also ask you to find v when I is 4. So that one is the same thing. So my v will be equal to, let's say, 2 times that 4, and then v will be equal to 8. As simple as that. Okay. Let's try another question where we have q varies directly as, say, x. Okay. So q varies directly as x. So in a given question now, they say q varies directly as x. So q varies directly, so on the same line as what? S. So q varies directly as x. So what this means is that I must change the vary sign into an equation and the constant of proportionality, so that this will become q is equal to k times what? S. So q is equal to k times s. So when you have that, then they ask you q is, say, 12 when s is what? 3. So q is 12 when s is 3. So this statement here will help you to find your constant of proportionality. This statement will always be part of the question, okay, to help you get your constant of proportionality. So that this will become q, which is 12. 12 is equal to k times 3. And that will be 12 is equal to 3k. Okay, so then my k is 12 over 3, which is what? 4. So in this our case, our constant of proportionality is 4. So when that is done, then you can rewrite your variation equation as q is equal to 4 times what? S. So any of them that you are given this time around, you can find. So maybe they can ask you, find q if s is, say, 7. So find q if s is 7. So q if s is 7. So our s now is 7. So our q will be equal to 4 times what? 7. And q is hence what? 28. As simple as it's simple. Okay. So then this is the whole concept about direct variation. In direct variation too, you can also use what we call cross multiplication. You know how we do that, right? Direct proportion. They call it direct proportion. Cross multiplication. So it's like saying, oh, if q is 12 and it amounts to 3. Okay, let me show you that. Instead of me going the direct way, using the variation equation and all that, I can just say, okay, q varies directly as s. When q is 12, what? S is what? 3. Good. So it's like I'll say 12 amounts to what? 3. So they are asking me to find q when my s is now 7. So it's like find q when your s is 7. So find q when your s is 7. Are they seeing it? So then you can just do this mapping and cross multiply so that you have this, which is 3x, which is this times that, is equal to 7 times 12. So 7 times 12. So at the end of the day, we are looking for the x, which is that q they are asking us. So over 3, then this place to over 3. So this will cancel this. So my x or my q, let me use q so that it doesn't confuse us. So my q here is going to be what? This will cancel this 4. So 7 times 4, which is going to be 28. Okay? So there will be no need to use the variation equation if it is direct variation. Okay? Unless, of course, the question states that you should find the constant of proportionality first before they ask you to evaluate the value for Q when S is this. Okay, when that happens, then that one you have to pass through the variation solution. If not, then you can decide to just use direct proportion. You will still get the same answer. Okay, so that is it about direct variation. That is it about it. So in direct variation question, you always hear them say something varies directly with another thing. So when that word directly is not there, then it's not direct variation. Okay. Let's go to the other one, which is inverse variation. Inverse variation. We have two types. You see that they are, when this is on the rise, this is also on the rise. Or when this is on the rise, the other one is going down. So this is inverse variation. Okay, inverse variation. So with this one, you will also hear in the question that a quantity varies inversely as the other. So the quantity varies inversely as the other. When that is said, then they are treating what? Inverse variation. Okay, inverse variation. So this quantity varies inversely as the other. Okay. Then when that happens, it's just a matter of what? Flipping the order. Okay, turn it upside down. So let's use our initial one, we want V and I. So let's say we say V varies inversely as I. So V varies inversely as I. So V varies inversely as I. So you just do 1 over I. So when you hear the word inverse, inverse simply means you interchange the position. And you know that every whole number that is standing is divided by 1. So if I say inverse of this, then that means 1 will go top and whatever is at the top will come down. So that's why it will not be 1 over I. Okay. So anytime you hear inverse, that is what it means. Right. So V varies inversely as I. Of course, you can't relate this to electricity, but this is not true. V does not vary inversely as I. Now this is just a quantity we are using. So V varies what? Inversely as I. Then the same idea from the joint from the direct variation. You just have to change the variation symbol into an equation sign with a constant of proportionality. So this is going to be V is equal to K, then times what? 1 over I. Okay? K times 1 over I. Right. So they will tell you when V is say 6, then maybe our K, our I as at that time is 2. So when V is 6, our I is 2. So you use that one to determine the constant of proportionality, just like the joint variation. So this one to put the 6 here, K is here, into bracket, 1 over 2. Okay? So that at the end of the day, when you do this expansion, you are going to get 6 is equal to K over 2. Then finding K, you just cross multiply. So 2 times 6 is going to be 12. K times 1 and it's going to be K. So our constant of proportionality K is equal to what? 12. So in this our case, our K is what? 12. So then if we want to rewrite our variation question using the value we have for the constant of proportionality now, then we only have to rewrite this and then replace this K by 12. So our new variation equation is going to be 12 times what? 1 over I, which is almost like saying 12 over I. The same thing. Okay. So now they can ask you to find I when V is this. Find V when I is this. Okay. So we can say find V when I is say 3. I don't want to use that. So find V when I is say 3. Then it's very simple. Now V is going to be V is equal to 12 over 3. and therefore v is what? 4. As simple as that. So you realize that if I increase I, my v will be decreasing, and if I increase v, my I will be decreasing. That's evident from here. You see, here the value of v is higher, which is 6, and therefore I came down 2. But here, when I reduce the value for v, I is cancelled, short up. Okay, so that is how the relationship always look like in inverse variation. So just like the joint, you could have the inverse variation mentioned in the question. So they will tell you a quantity varies inversely as another quantity. So with a direct to, they will tell you a quantity varies what? Directly to another quantity. Okay, but here is inverse. So anytime you hear inverse, then the first quantity varies then 1 over the second quantity. Okay. Now, before I proceed to the very last aspect of our first video on variation, let me make some differences for you, because they normally mention such differences. For instance, we have something we call cube and cube root. We have square and square root. These 3 or 4 items actually confuse. Okay, when you hear v varies directly as the cube of x, v varies directly as the cube of x. Most cases, students go and rather represent that by a cubic root. It's not true. They say v varies directly as the cube of x. So what they are saying is v varies directly as the cube of x. So that is s cubed. Okay. So v varies directly as what? S cubed, as the cube of x, s cubed. But when they say v varies directly as the cubic root of x, then that one is going to be v varies directly as the cubic root of x. So please take note of that, right? So v varies directly as the cube, then this is v varies directly as the cubic root. So until the root is mentioned, don't bring this word symbol. Okay, so with this one, if you want to work on this, then it's going to be v is equal to k times what? S cubed. And let's say we are finding our x, for instance. We know the k already, so v over k is equal to what? S cubed. So you are looking for x, not s cubed. So how do you eliminate cube when you have that? We eliminate a cube using a cube root. So when you are doing a certain algebraic expression like this, and then you want to remove the powers, you use cube roots to remove powers. Okay, remove exponents. So if it's 3, you use the cubic root. So the cubic root is going to take care of it. So you must do same for this side as well. Okay, so those are the differences. And here too, if you want to eliminate the cubic root, then you have to cube it. You have to raise it to the power 3. Okay, you have to raise it to the power 3. Then this 3 is going to cancel the cube root for you. So we eliminate roots using powers, and then we eliminate powers using roots. So they are just opposites. Okay. So when you hear cube, this is what it means. Cubic root, it means this. Square, it will be s squared, and then square root would be the normal root sign, you know. So these two are very important. They can still happen under inverse as well, where this could also be v varies inversely as the square of x. So then that would be v varies inversely as the square of x. So that one is going to be v 1 over s squared. Okay, so that is about inverse variation and then direct variation. Actually, they are this simple. It's not going to be a whole lot. Okay, so before I conclude this video, I want to introduce you to the very last aspect of this. That is what we call a hybrid. In hybrid means you are joining two different items that are having different characteristics, but you want to make them one. So then we call it joint variation. So with a joint variation, what that simply means is that we are trying to combine two different quantities to relate a specific quantity. Okay, two different quantities to relate a specific quantity. So, like I said from the early on preamble, when you want a good life, you eat well and then you exercise. So you see, eating and then exercise, all of them relates to good life. So then we will say, okay, then good life varies directly as eating well, and good life varies directly as what? Exercise. So these two quantities are relating the same what? Good life. So when we have that situation, then we can combine them into a single variation, and then we call it the joint variation. Are you okay? Or you can have the situation where one will be direct and one will be opposite. What that means is that we can say, okay, good life varies directly as eating well. Okay, so it means that, okay, good life and eating well goes together. When you eat well, you get good life. But we will say, but inversely proportional to drug abuse. Okay, so it means that the same good life is having a direct relationship with eating well. That means that when you are eating well, your life is going up. Okay, but when you are abusing drugs, then your life is actually coming down. So we don't want to do two separate variations, but we want to combine it to have the same what meaning. So when we do that, then we say it's called the joint variation. So in joint variation, it can be inverse, direct, or direct and inverse. So you have two different inverse relationship or two different variations inside the single question. So that is what I want to introduce you to, joint variation. So for instance, I can say, so this is joint variation. So I can say, okay, V Q say varies. Q varies directly as what? As the square. Q varies directly as the square of V. Okay, Q varies directly as the square of V, and directly as say T. Okay, so they are saying Q varies directly as the square of V. That is a single variation relationship, and directly as the square of T. So you can actually say Q varies directly as T. That is one variation. Q varies directly as the square of V, another variation. So you have two different quantities, but they are all relating the Q. Then this is a sample of a joint where both of them are direct. So it's simple. We say what? Q varies directly as what? The square of V. So as V squared. That's the very first one. So there is the first one. And then they are saying that Q varies what? Directly as T. You see the end there means that this same Q is varying directly as T. So Q varies directly as T. So this is the second variation. Okay, but then we can't be doing two variations here. We can what? Just decide to compress them. Okay, so Q is Q, vary is vary, but these are two different what? Items. So what we can do is what? To fuse them together, and therefore this will become Q varies V squared. The same line is where the T is, so V squared and then with T. So when you do this, then we say this is what? A joint variation. A joint variation, because this Q alone is having two different quantities is varying with. Okay? So then the same old tradition follows. You just change the variation into normal constant of proportionality. So this one will be Q is equal to K V squared times T. So they will give you at the initial stages the value for Q, the value for V, and the value for T. Then you just insert them here and you get your constant. After that, they will give you maybe Q and V and ask you to determine T. So you just change the subject. Or they will give you Q and V and ask you to determine Q and T and ask you to determine V. That one too is also there. Okay, so that is how everything is right with the joint variation. Or this very question can also be changed into a more hybrid format where this is not Q varies directly as the square of V. Fine, but then they will say what? But what? Inversely as T. Okay, but inversely as T. So it means that this Q is having a direct relationship with V, square of V. But then, when it comes to what the relationship with what T is inverse. So this is the same as the first one. Break them down into two separate variations and combine. So the very first one, Q varies directly as the square of V. So as V squared. Okay? And they said that the same Q varies inversely as T. So 1 over T. You see, so fusing these together, see this is on the same line, but this is on at the down. So if I want to fuse them, QQ, then I replace it Q. Vary. V is at the top, so V squared. And at the down, T is here, so V squared over T. So it's just a matter of getting the two variation sets and then fusing them into one. When you do so, then you will say that you can have your variation now in the joint format. Okay, then we call it joint format. Then the whole history and everything, that's it. So in variation, the whole idea doesn't change. Whether it's direct or inversely or joint or the same thing. Okay, the same thing. So just in joint, break it down and then fuse it. And that is it. Okay. We can even make V varies inversely as the square of V and inversely as T. So you can have that here. Then I'll write that for you. So inversely and inversely as T. So with that one, both of them are now inverse. So Q varies inversely as the square of V. So this is also 1 over V squared. Okay. So then when I fuse the two, this one is at the top, one is at the top. So here too, one will be at the top. Then V squared is at the down. V squared is at the down. T is also at the down. So at the end of the day, after fusing, we are going to get it. Q varies inversely as V squared T. Okay, so that is how the joint variation and every single format works. And like I said, to evaluate the joint variation, then what did we say? We said that we are only going to fixing the first three values of the preamble they will give us, and then after we are done with those ones, then they will give us two of the items, then we find the order. Maybe they will give us v squared t and v and t, then we find q. Or we can be given q and t, we will find v. All those things are just change of subject, algebraic expressions. Okay, algebraic expressions. So then that one is not really so much of what ahead. Okay, I'm very sure that you enjoy our today's lesson on the first part of variation. Before I leave you, I'll leave you with this exercise. Display. You can always contact us if you have any challenge, and then we'll be ready to assist you. Okay. Watch out for our next video as we do the second part of variation, which is partial variation. Then we shall end our total lesson on variation.
No phone canson, many telephone, no go hey, get many okay no, ni echo back on down, get no okay country go, she boom open